மலையடிவாரத்துல பச்சை பசேல்னு இருக்கிற இடத்துல படிக்கிறதுக்கு நல்ல ஒரு ஃப்ரெண்ட்லியான என்வாயர்மெண்ட் தான் நம்ம SCAD Polytechnic காலேஜ்.
கல்வி சேவையில 36 வருஷம் அனுபவம் பெற்ற SCAD கல்வி குழுமங்களின் நிறுவனத்துல ஒண்ணுதான் இந்த SCAD Polytechnic காலேஜ்.
தரமான வசதிகள் நிறைந்த விசாலமான வகுப்பறைகள், எல்லா ஃபெசிலிட்டியோட லேப்ஸ், ஒர்க் ஷாப்ஸ், கேர்ள்ஸ் அண்ட் பாய்ஸ்க்கு செப்பரேட் ஹாஸ்டல், காலேஜுக்கு போயிட்டு வர பஸ் ஃபெசிலிட்டி உள்ளதுதான் நம்ம SCAD Polytechnic காலேஜ்.
மண்டல அளவிலான ஸ்போர்ட்ஸ்ல தொடர்ந்து 9 வருஷமா ஓவரால் சாம்பியன்ஸ் இவங்க தான்.
கோர்சஸ் ஆஃபர்ட்: சிவில் இன்ஜினியரிங், மெக்கானிக்கல் இன்ஜினியரிங், automobile engineering, electrical and electronics engineering, electronics and communication engineering, computer engineering.
போர்டு எக்ஸாம்ல நல்ல மார்க் ஸ்கோர் பண்றதுக்காக ஸ்பெஷல் கோச்சிங் கொடுக்கறாங்க. ஒவ்வொரு செமஸ்டர் எக்ஸாம்லயும் ஸ்டேட் லெவல்ல ஃபர்ஸ்ட் 5 ரேங்க்குள்ள ஸ்டூடண்ட்ஸ் எடுக்கறாங்க. 100% பிளேஸ்மெண்ட்டும் வாங்கி கொடுக்கறாங்க. சோஷியல் ஆக்டிவிட்டீஸ்லயும் நம்பர் 1 காலேஜ் தான் நம்ம SCAD Polytechnic காலேஜ். இந்த பெஸ்ட் காலேஜ்ல படிக்கணும்னா உடனே கால் பண்ணுங்க.
செல் 999429 78528.
Good evening. It is my privilege to welcome our resource person, Dr. V.Piramanantham, Associate Professor, Bharathidasan University, Tiruchirappalli. He is a great scholar and such a talented person. Next, I welcome our Chairman Sir and MD Sir. I welcome our AGM and Principal, Mr. J. Manimaran Sir, for giving such a wonderful opportunity. I welcome
Good evening, everyone. At the outset, I would like to thank the SCAD group of institution, respected chairman, principal of SCAD Polytechnic College, the coordinator of webinar, and the organizer, Mr.V.Vignesh. Okay, the topic of the webinar is introduction to GeoGEBRA software. Commonly, it is known as the GeoGEBRA app because it specifically works only for geometry and algebra constructions, right? So people commonly mathematicians call this as GeoGEBRA app application. Okay, first I am going to start with the concept that how to download the GeoGEBRA software and what are the varieties of platforms in which GeoGEBRA works. First, let us start with the method of downloading, right? First, we go to now you are seeing my screen on which I have opened the Firefox browser. In the Firefox browser, you type the address geogebra.org. Right? This is a GeoGEBRA website. In this website can be treated as a Facebook, like a Facebook page. This is called a GeoGEBRA page, right? So in this GeoGEBRA page, you look at this, this part. Here we have stat calculator and the classroom resources. On the right side, you can see my photo. Already I have logged in the GeoGEBRA page. And also in the menu bar of the page, we have home, news feed, resource profile, people, classroom, and the last one is app download. So here you can download GeoGEBRA. There are varieties of apps. First app is graphic calculator, and the second one is 3D calculator, geometry, and GeoGEBRA Classic 6. This is the bundle of other applications, right? The augmented related. And this is the old version of Classic 6 and Classic 5. But there are other variety of perspectives. Okay, you see the more download, more. Okay, so it's better to, if you are installing in the computer, it's better to download Classic 6 app, right? Okay, now now I explained the app GeoGebra. The name GeoGebra comes from geometry and algebra names, right? First part of geometry and the second part of algebra is taken to name this software, right? So this is geometry algebra interconnecting software, okay? And it is mostly interactive software. Okay, it allows you to construct mathematical concepts dynamically, right? So it is called a dynamic mathematics app. Okay, and it works in 3 platforms. One in desktop and another through web app you can work, and the third one is you can install in the mobile phones. Okay, so the first one is this can be work treated as a web app. For how to open the web app means you open the web page, GeoGebra web page, and here you see the start calculator. If you click start calculator, the software will be opened in the browser itself. Okay, this application is called web app, right? The second one is you go to app download. Here you see the download button. You click the download button for a variety of applications. If you want to install graphing calculator, 3D calculator, geometry, everything in as a single software, you download GeoGebra Classic 6 software, right? You download this Classic 6, then it can be installed in your computer. Whether your computer has a Windows OS or a Linux OS or a Mac OS, no problem. In all 3 OS, it will work, right? And the third one is you open your Google Play Store in the mobile or tablet. In the Google Play Store, you search GeoGebra, then you have, okay, you will be seeing the GeoGebra, okay, list of softwares in the Google Play Store. Then you install in the mobile also. So it works as a mobile app. Already in my computer, I have installed GeoGebra Classic 6 software. Right, I will show you the original software. Right, this is the GeoGebra 6 Classic 6 version. Right? This is the latest version. Okay, now you can see the several components of the GeoGebra software. Okay, now this window is a GeoGebra software. There are several components are there in the GeoGebra software. Here you can see that GeoGebra Classic version 6. Here there are several perspectives. You can, if you click graphing, you will see the graph sheet and its corresponding algebraic equation, algebraic view. And you can also work in this geometry, like a practical geometry, what we are doing with the geometric instruments. That can be done in the computer itself by clicking, okay, the menus. The third one is 3D graphing. It's very important and it's a wonderful perspective. You can visualize 3-dimensional geometric objects in the computer. The other one is computer algebra system, spreadsheet, probability. Other things are okay later developed. Initially, when the GeoGebra software developed with these 3 perspectives. This list is called perspective list. Right? Once I click in that window, the perspective will disappear. Now what you are seeing is the GeoGebra graphing calculator. Right? In the graphing calculator, there are components. I will explain one by one. So, in the top left, we have 10 tools. Right? This is called a toolbar. Okay. Here, if you click one toolbar, then you will see the list of tools. These are all geometric tools, right? So this is called toolbar or a geometric bar, you can say. And top right corner, you have 3 lines, and if you click on that 3 line, you will get a menu bar, right? This is a file, you can open new file, open existing file, save the file, and edit. Here we have views, algebraic view, CS view, graphing view, right? And so on, right? I have selected algebra and the graphics. So in my GeoGebra application, you can see 2 views. In the left hand side, okay, plain sheet, you will see this is algebraic view. The right hand side, you can see the graph sheet, right? You can zoom the graph sheet to any level, right? Zoom out or zoom in, right? And also below the menu bar, you see a small bar which is called the style bar, right? Now the style bar opened for the graph. Okay, if you want to hide the axis of the graph sheet, click this, right? If you want to see show the, once again you click. Here we have different type of this is a Cartesian coordinate system. If you want to see the polar coordinate form, you take circle and lines, right? But I select, you can remove that meshes also. So now you see the plain graph sheet with the axis. After you can remove the axis also, you will see the geometric view with the plain, with the plain paper. So now I show the axis and meshes, right? For Cartesian coordinate. This is the style bar. And fourth one is the navigation toolbar, which is given below the graphical view, right? This gives you the step-by-step explanation for different geometric constructions, right? Another component is the input bar. You see in the algebraic view, whatever thing you want to give input through keyboard, you can do, right? Suppose I write f of x equal to x square, right, in the input bar, then its graph is shown in the graphics view. Okay, I put enter. Then in the algebraic view, you have f of x equal to x square function. In the graphics view, you can see the corresponding parabola. Okay? Actually, it's y equal to x square, right? And also you can draw the graphs or the geometric objects using the tools or by directly giving input in the input bar. Okay, and another important component is the context menu, which is which appears by clicking on the object, right? You just click on the object and right click, you will see the menu which is called a context menu. And each geometric object has its own settings. So right click on the object, click setting, then the setting will appear in the right hand side, right? You can change the color, change the style, change the point view, right? And more advanced settings are there. And the basic setting is you can change the name also. I have a point A here. Suppose I don't want A, or I want A1 means A_1. This is the usual computer format, right? So I have changed the name of the point as A1, right? You are able to see the name of the point and the name also, right? And if you click on the graphing view, the style bar gives the graph properties. If you click on the point, the style bar gives the styles, right? Here also you can change the colors, and also you can change the point style also. You can put into mark point, round point, right? Like that. Okay, this is the main components of GeoGebra application. Now I will explain in the tools given in the toolbar one by one, and then I will show the construction of certain geometric activities. Now you can also delete the geometric objects by clicking on the delete button, right? Now you see several toolbars are there, but first tool is the move, freehand and shape and pen tool, right? The move tool used to move the geometric objects okay, inside the graphics view. Suppose I have a point, AB points are there, right? I cannot directly move this point AB. I have to select the move tool to move the point A, right? And also in the algebraic view, we see when I create a geometric object, that is this point, its coordinates are displayed in the algebraic view for both A, B. If I change A, then what happened? The coordinates also changes, right? So the point placed in -3, 3 place, right? That means the left x-axis side you have -3 distance and the y-axis positive side. If I take this point to the first quadrant, the both coordinates are positive, right? X positive axis or y axis. If we take the point to the third quadrant, right? The coordinates of both A, B are negative. If we take the point to the fourth quadrant, then what happened? The x is positive, y is negative. Okay, this can be shown to the student also, right? This software helps us to learn geometry easily, right? By visualization. Okay. Okay, this move tool used to move the objects here and there, right? And the second tool is a freehand shape. Once I select the tool, that will appear in the top, right? Then in the geometric view, you will see a pen. Okay, you draw, okay, a line, then it gives a, okay, line. But if I draw smaller lines, and that will give a perfect line segments, right? Suppose I want to draw the circle, I have to draw the circle approximately. It gives, okay, this gives the exact circle, and this is called a smart, okay, recognition. And the last one is pen tool. Okay, unlike in the freehand shape, if you want anything, if you want to write anything in this graphics side, you can write using this pen tool, right? And also I write something. This will be useful when you use the smart pen in the tablet to write, right? And by writing in the mouse, it is very difficult. So this tool is useful when you use the GeoGebra app in the mobiles. So in the mobile, your touching the screen is treated as a mouse, right? So if you touch and write using your hand, then you will get a good handwriting, right? So here I have written using mouse, so you cannot see a perfect, right? These are three important tools. Next tool is the point and point tools, right? So now we take the new page. I have taken a new page to explain next toolbar. Next toolbar is points toolbar. So first is point tool, then point on the object tool, detach, attach, point, intersection, and so on. First one is a point tool. I select the point tool in this tool. But if I click in the graph, then you will get different points, right? Okay, once I click, then you will get a point, right? Still the point menu is selected, right? So if I click on another side, then you will get another point. Okay, how many clicks I click, then you will get a point. Okay, so if you want to change the menu, you have to change the tool. You have to go to the tool menu and you have to change. Suppose I want to use a move tool, then I have to go to the tool menu, toolbar, and select move. Now you see, when I select point tool, right? If I click, you will get a point. When I select move tool, right? If you click, nothing will happen. If you select a point and move, then it will move, right? Okay, if you want to move any point anywhere, not only for this points, here for any object. Suppose I have a circle. Okay, the move tool used to move the circle, right? So you are able to see the circle and the center, right? If we move the center, also the circle moves with the center. Okay, if we move circle, center also moves with the circle. Okay, so the move tool used to move any geometric object within the graph sheet, right? And also next one is point on the object. If you want to place a point on the object, then you can place the point on the object. Go to new page, right? Suppose I have a circle, right? You are able to see the circle, and suppose I have a line, right? If you want to create a point on the line, you have to choose the tool point on object. Once if you choose the tool, you will see in the bottom that the GeoGebra tells you that select object or its parameter, right? So to use the point on object tool, you have to select object in the graphics side. So I'm going to select the straight line to place point on the straight line, right? So once I clicked on the straight line, then you will have a point on the straight line, right? So now we see what is the difference between point and the point on the object. I take a point F, which is not on the object. Now we have point E on the object. Now I'm going to track the points by using move tool. If I move the point, then it moves wherever I track the mouse, right? It goes inside the circle, it goes below the line, above the line, right? But I have created a point E, which is on the object, which is the straight line, which is created on the straight line. If I move the point horizontally, the point moves on the line. Suppose I pull down the point, it will not come. It will be always on the straight line, right? Suppose I take a point on the circle G. So point G is the point on the circle. If I move the point, it moves only around the circle. It will not come out of circle, right? Right? Okay. The next tool is detach attach point, right? So this tool used to detach a point from the object and attach to the object. Okay. Now we have point E, which is not on any of the objects. I'm going to attach the point F to the circle, right? So I track this point and attach with the circle. Now the point is attached with the circle. Already we have point E on the straight line. I'm going to detach. Just click and track, it comes out of the line, right? Now you move the points. The point E, now it gets freed, though it is moving in a graph anywhere. But the point F is attached with the circle, so it will not move anywhere except the circle. It moves only through the circle. If I pull out of the circle, it will not come. Pull in, it will not go, but it will move around the on the circle. So this is a very important tool. Next tool is intersection tool. It creates intersection of two curves, right? I have curve circle and straight line. I have moved the straight line so that it intersecting with the circle. Now I am going to use the intersection tool. Once I select the intersection tool, it tells you to select two objects to find the intersection of two curves. I choose circle and straight line. Then you see H and I are 2 points, which is the intersection of straight line and circle, right? Now you suppose I use the move menu to move the straight line, right? So then the intersecting point also moving, right? So this is the power of GeoGebra, right? Now, and one more information about this geometric objects. We have 2 categories of objects, right? And I will see in the algebraic view. I have listed the objects, appearing in the geometric view as a 2 categories. So first one is free object and the second is dependent object. Free objects can be moved anywhere, right? It can be moved anywhere. Dependent object moves, okay, depends only on the object. Suppose I move the circle, right? Then the point on the object, on the circle F, right? And the intersecting points are moving, okay? So the F and Hi are dependent objects, okay? Whereas circle is dependent, right? Whereas point on the, suppose I select this, you see the points used to create the circle in the straight line. A is the center of the circle. If I move the center, the circle moves, and the circle depends on the center, and the intersecting point H and I are, okay, points depends on the circle and the straight line. So if I move circle or straight line, intersecting points moves, okay. So B is the point used to construct the circle. So if I move the point B, also circle will change, right? So how the circle constructed? I have used the circle with the center through point tool. I have to select 2 points. One is the center, another one point will be the point through which circle goes. Okay, the circle is constructed, okay, using 2 points. Okay, now we see the track test. If you move the point J, center of the circle, it moves. If I move the point through which a circle goes, circle moves. Suppose I take a point on the circle, right? There are difference between these 3 points, right? J, K, L, right? J and K are used to create the circle, but L is the point, okay, created on the circle. So if I track L, circle will not change, but the point will move in the circle. If I change K, the move circle, okay, changes. The main thing in this is J and K are independent objects, free objects. Circle and the L points are depend on the 2 points J and K, right? Next tool is the midpoint tool, right? So if you want to use the tool, we have to select 2 points. I select the midpoint tool that appears in the top. Okay, if I select 2 points A, B, then this tool creates midpoint C, right? In the geometric you see C equal to midpoint of AB. A is the coordinate -6.42, 2.51. B is -0.84, 3.33. The midpoint is this, right? And also I can, suppose I have 2 points D and E. I'm going to create midpoint using input tool, right? Now what is the formula for finding midpoint? If I point A or B, A plus B by 2 is the midpoint, right? So I'm going to calculate the midpoint for D and E. So D plus, right? I'm going to D plus E divided by 2, right? This is the midpoint formula. Enter, okay? Then you have a F midpoint of D and E. So you can create midpoint of 2 points using tool, and also you can use the input bar to find, okay, create the midpoint. So F is the midpoint of D and E, okay. And the next tool is the complex number. Here, first menu creates the points, okay. When I create a point A, B, right, C moves with it because C depends on AB, right? When I create A, then its Cartesian coordinates are displayed in the algebraic view, right? When I use a complex number, okay, tool, I click on the plane, then that tool treats this graph as a complex plane, right? I have created Z1 using complex number tool. You see in that algebraic view, you will see A plus IB formula, right? Suppose I move the point in 1, 1, you see 1 plus I. If I take 2 comma 1, then 2, 1 plus 2i. We place the complex number in 2 comma 2, you see 2 plus 2i. Right? You can also create the complex number through input bar. Okay, 3 plus 4i. Right? I write 3 plus 4i in the input bar, then it creates Z2 in the graph, right, in the complex plane. So complex number tool treats this graph as a complex plane, right? Other tools treat this as a graph, right? This is what, okay. Then you check whether if you want to create a midpoint between Z1 and Z2, then use the formula, right? Z1, Z underscore 1 plus Z underscore 2, right? This is the addition of two complex number, but I want to create midpoint, right? So start bracket Z underscore 1 plus Z underscore 2 divided by 2, right? Sorry, something. How to write the by 2 out of the bracket. Z underscore 1 plus Z underscore 2. So Z underscore bracket Z underscore 1 plus Z underscore 2, close the bracket, divided by 2, right? The Z3 is the midpoint of Z1 and Z2, it is created. You see, you zoom and I will zoom the graph and show you, right? Z1, Z2 are 2 points, Z3 is the midpoint of the complex number. Okay. The next tool is turning point and root. So if you have a polynomial equation, you can find the root and you can see the maximum, local maximum and the local minimum of the curve. So for that I take new GeoGebra window, right? Suppose I have a polynomial, okay, you write this in terms of equation, x square minus 4x plus 2pi, right? Enter. So y equal to x square minus 4x plus 2, okay, is an equation which is whose graph is the parabola, right, in the xy plane. So this is the parabola you have, right? If you want to find the root of x square minus 4x plus 2 equal to 0, then you have to fix y equal to 0. So y equal to 0 means it's in x-axis, right? So finding root of a polynomial, quadratic polynomial is equivalent to finding intersection of parabola with the x-axis, right? So further, how we find, generally you can use the intersect menu, right? Interact tool. Okay, you select the intersect tool, okay, click on the parabola and click on the x-axis, then it creates 2 points, which is the intersection of parabola and the x-axis. Right, now tell me the roots. You see in that algebraic view, you will see point A and B, right? Point A is 3.41, point B is 0.59, comma 0. So these two are roots, right? Otherwise, if you don't want to use the intersection, but if you want to use that root rule, you select the root tool and select the parabola. That also gives the intersection of the parabola with the x-axis, right? The same value you will get, right? If you want to find the minimum value of this parabola, then use the turning point tool, right? Select the turning point tool and select the parabola. You see that this parabola turns at the point C, right? So at the point x, the x equal to 2, the parabola turns, towards left. Okay, it is decreasing and it become increasing at the point C. So smallest value of the parabola is minus 2 because C in the height of the C from the x-axis is minus 2, y coordinates minus 2, x is 2. So the parabola has minimum value at the point 2, the minimum value is minus 2. Right? Okay, this is the use of turning point and the root. If you want to use, okay, turning point in some other way, you write y equal to sin x. Okay, I'm going to draw the sin x graph. Right? Now you see, I write in the input bar, I write sin of x in the input bar. Okay, then you can see the sin x graph, right? For each function, you can find a graph in the graphics view. I have zoomed out the graphic view. You see up and down the graph. Okay, sine graph. Okay, if you want to find the root of the sine, value sin x, that means suppose I want to find the point x for which sin of x equal to 0. Use the tool root. Right? Select root tool. Select the sin x graph. Then you see A, B, C, D are roots of sin x. Right? You zoom out, then it will create a lot of it. Okay. Wherever the sin x graph intersects x-axis, okay, that point will be shown in the graph. Right? Suppose I want to find the turning point of the sine graph. You click the turning point tool, select the sin x graph by mouse, then you will see the turning points. A is the upper, okay, right turn point, B is the left turn point. You see that if you are walking along the sine graph, you will see turning at A, B, C, D. Alternatively, you will take left turn, right turn, and so on. Right? So right turn gives the maximum value of the sine function. Left turn gives the minimum value of the sine function. Right? So maximum value always 1. You see A, C, E, F, R. Okay, gives maximum value. A gives 1, C gives 1, E gives 1. See B, D, E, F are okay. The points give minimum value, right? So the minimum value is -1. So the sine graph, okay, runs lies between -1 and +1. That can be confirmed. Suppose I take y equal to 1 line. You see, I have drawn y equal to 1 line. I'm going to draw y equal to -1 line. Okay. So I've drawn 2 lines, right? Y equal to 1, y equal to -1 line. So the sine graph lies between y equal to 1 and -1. You zoom out, then you will see it. Okay. So next tool is line tool, right? This can be used to create lines and vectors. First tool is line. Okay, straight line. You select the tool and you select 2 points. Okay, if there is no point on the graph, click on 2 places, then you will get a line passing through the points, right? Once I click, then you will get a point C, right? Then I move the mouse away from C, then the GeoGebra is ready to draw the line, okay, and it is waiting for the second line, the second point. So it is waiting, and if I click somewhere, and it immediately draws the straight line, right? Suppose I click here, draws a straight line, right? You want to create a line segment. Suppose I have 2 points, okay, on the graph. Okay, if you want to find, okay, draw the straight line passing through EF, you select the straight line tool, click E, and click F, then you will have a straight line passing through EF. So if you have already 2 points, then you can draw a line. If you randomly, you can select 2 points and just draw the line, right? So this is a line tool. Next tool is line segment, right? So the first one is straight line, completely infinite straight line. The second tool gives a line segment only, line between 2 points. Right? This okay, you can select. And the next one is segment with the given length. Right? How do you find the line segment? You have to select a point through which line goes, right? So I click, okay, I select the point, then the GeoGebra asks you to give the length, right? So I give 3 length. Then by default, the GeoGebra draws straight line segment, starts at E, okay, with the length 3, right? Horizontal. By default, it gives horizontal line. Right? Now I am going to use the move tool to move the points. Right? Suppose I move the point E, right? The line segment moves with E, right? Suppose I move F, moves. Okay. Suppose I want to change the length of the line segment for the third line. You cannot do because the line segment created with the fixed length 3. So if I track F, it will not come. Okay. You can move the F around E. That's all. Right. The length will be fixed. But whereas in the first line segment, length is not fixed. I have fixed 2 points and created line segment. Right. So the length is not fixed. A and B are 2 points you can move. Right. And third one is ray. Okay. It's a half straight line. You select a point. I remove it. I select, we have to select 2 points to draw the ray, right? One is the starting point, another one is the point through which ray can be drawn. I select A, then the GeoGebra is ready to draw the ray. Ray means half line. Okay, infinite line starts with the point. Okay, I select B so that you get a half line. Right? Zoom out the graph, then you will see half line only, right? This is the ray. And the fifth tool is the polyline tool, right? This polyline is tool to draw the polygonal path. I take, suppose I remove this ray. Here we have 6 points. I am going to draw a polygonal path between these 6 points, right? I select the polyline tool. I am going to start with A, then B, one line segment. If I select E, then it creates another line segment, right? Then D, E, then F. I have to stop with this F. If you want to have one more line segment, but a point is not there, but you can create a point, right? You can create polygonal path. Polygonal path is the piece of line segments connected at the edges. So you want to stop with J means you have to click on A so that the polygonal path completes and it starts from A ends with the J. Right? This is the polyline tool. Right? The next tool is vector tool, right? So I take new window, right? I'm going to create a vector, right? You select the vector tool, you select a point which is a starting point of the vector, and you select another point which is the end point of the vector, right? Now, if I select a line segment, the algebra view says line, right? I select the big difference between line segment and a vector is the following, right? You see, you have a vector, right? We have vector between AB. Here we have a line segment between CD, right? Now we see in that algebraic view that U is the vector, okay, starting at A, ending with B, okay, the coordinate, okay, the vector components are 5 point something, 2 point something. Now here F is the line segment, right? So the segment between CD. So in the algebraic view, you see segment, vector, okay, that difference will be there, right? And also vector, in school days we have studied that vector has a base point and okay, ends with the point with the arrow, right? So it is displayed as the arrow. Vector is always displayed as arrow. And the last vector from point means if you want to create a vector at this point, right? At a point, I select a point here, right? If you want to create a vector at G, which is parallel to AB, then you select. You see in the below, when I select the vector tool, select starting point and vector, right? So this tool used, okay, by selecting a point G and a vector U. So once I click U, then you will get a vector at G which is parallel to AB vector, right? Now use the move tool to move this, right? Suppose I move G, the move vector moves, but there is no change in the direction, right? Because the direction of G dash is always direction of AB, right? And the vector is just a translate of AB, right? U here V vector is the translate of, if move this vector B and you fix with G dash, it coincides, right? So G dash is the translate of AB, right? Suppose under the length of G dash is same as AB. If I change the length of AB, right, the direction of AB, the dependent vector changes. G dash direction changes. Okay, this way we can construct two vectors, right? And the next tool is the perpendicular line, parallel line, perpendicular bisector, and so on. So you can draw a line which is perpendicular to some other line passing through a point. So for that I have to take a, okay, we must have a line, right? Then I have a point C. Suppose if you want to find a perpendicular line passing through C and which is perpendicular to this line, you can use the perpendicular line tool, right? So you select the line for which perpendicular line should be drawn, right? And I click C, then you will get a line perpendicular to this AB line and passing through. So I remove the axis, then you can see, right? Suppose I move the point C, then perpendicular line moves, it will not rotate because the line G is always perpendicular to the fixed horizontal line, right? If move, C moves. Okay, the vertical line is perpendicular to the horizontal AB. So if I move the line AB, then perpendicular line also correspondingly moves, right? So because you see in the independent, you see the algebraic view, ABC are independent points. Dependent objects are line and a perpendicular line. So line is dependent on AB. So if I move AB, line moves, right? But the second line is always perpendicular to the first line. So first line is moved means second line also automatically moves because it is always perpendicular, right? Suppose I want to find a parallel line to this line. So use parallel line tool. Okay, select the point and select the object, then you will see the parallel line, right? Okay, so we have a parallel line which is passing through C. Suppose I move the point C, then parallel line moves, but it is always parallel, right? Suppose I move the first line, the parallel line also correspondingly moves. Okay, so the way of construction is the second line is always parallel to the first line. So whenever I change the first line, second line also changes. Okay. There is a next one is perpendicular bisector. Okay, I remove the perpendicular parallel vector. I remove C also. Now I have a line, right? In particularly, you consider only the line segment between AB, right? So I remove the line. I draw line segment between AB. So you have seen in the geometry class that there is activity that which is you, okay, which draws the perpendicular line which bisects the line segment, right? So that's a tool, perpendicular bisector tool. Okay, you select the segment, immediately it gives the bisection of that line segment. So this line, second line is the perpendicular bisector of first, okay, the line segment. Now you do that track test. By change AB, okay, line segment changes, the perpendicular bisector also changes, right? But I cannot move the perpendicular line. If I move the line segment, it changes. right? Okay, next, when suppose I find the intersection of the perpendicular bisector and the line segment, okay, it creates C, right? Right, C is the point, okay, which is in the middle of AB. So this perpendicular line bisects the line segment into two equal parts, okay. The intersection point is C. So now we have to verify that it is perfectly bisecting or not, right? So for that I am going to use the length or distance tool. Okay, this tool is to find the length of, okay, line segment or a length between 2 points, right? Distance between 2 points. So I select A and select B, right? The AB line length is 9.25. Then C is the middle point, right? It bisects the line segment into two. So I'm going to use the same tool, distance length tool. Now I'm going to find the length between A and C. It is half, right? Half of 9.25. It's a, if I select B and C, here also you see distance between BC is 4.62. For actually 4.625, but it is truncated by the computer, right? So now we can verify this. Okay, C is the midpoint of the line segment by using input bar. So in the input bar, I'm going to write distance between AB, right? Length of, okay, distance. I'm going to use the tool distance. I write a distance, right? Distance between point and object. A, we'll test this B. You see distance between AB here, right? I remove this. It gives the distance between AB, right? Segment F. Okay. So this is a perpendicular angle bisector bisects the angle into two, right? Suppose I have two. You take the new window, right? Suppose I have line segment AB and AC, right? You measure the angle between ABC, right? The angle between ABC can be measured in the counterclockwise direction. So in the counterclockwise direction, you have to select B, A, then C, right? The angle tool used, right? So angle between BAC is 107.09, right? The angle bisector bisects this angle into okay, 2. So for that you select A, B, A, then C, right? So first angle is the alpha, is the angle between A, B, A, C. Now you take a point on this straight line. D is the point on the bisector, right? Angle bisector. Now what will be the angle between BAD and DAC? That is half of 107.09 approximately, right? So I'm going to measure the angle between B, A and D. That is beta, right? So beta is the angle half of the alpha, right? Now I'm going to verify this. Beta in the toolbar, in the input bar, I'm going to write beta. Okay, I put a double equal, then it equal question mark creates. That means I'm going to verify whether beta is half of alpha or not, right? I type alpha divided by 2. Okay, so beta is half of alpha, so that is true, right? That is given in the algebra. So it but in the line H, okay, really bisects the angle BAC. So that is a use of angle bisector. And the next tool is a tangent, polar, and so on. So it is a little advanced. So we can draw the tangent. Suppose I have a circle, right? We want to draw a tangent of the circle at any point, you use the tangent rule, right? I'm going to create a point on the circle, right? Create a point on the circle B. Okay, now tangent should be created at the point B and to the circle, right? So the line F is the tangent line, right? Now use a track test. The point B is created on the object, so it will not come out of the circle. But wherever B goes, the tangent also, okay, drawn at the point. If I move A, the circle itself moves, the point B and the line also moves, right? Okay. And the very important tool is a best fit line, right? So I erase the tangent, erase a circle. Suppose we have some points here, okay? Then I am going to, okay, draw a straight line which is close to all the points, okay? So best fit line. If I select best fit line, it tells you to select several points or list of points, right? So I'm going to track, okay, mouse to cover all 5 points. So I have tracked the mouse to collect all the 5 points. Then I release the mouse, then it creates a straight line which is close to all the 5 points. Okay, this is the best, okay, fitted straight line to all the 5 points. In the algebraic view, see F is the fit line A, B, C, D, E. Right, that is y equal to 3.28, that is horizontal straight line, right? Suppose I use a move tool to move point A, right? The point also moves. Suppose straight line moves, because straight line depends on all the 5 points, right? You see now the equation changes, equation of straight line changes, okay, according to the 5 points. Also, we have one more command, which is the best polynomial fit, right? Fit polynomial. In the input tool, I write fit poly, right? Fit polynomial. For that, you have to select list of points and the degree, so that it will create the polynomial of degree. Okay, enter. So I put fit polynomial. Fit poly of, I have to select point A. Otherwise, I take these 5 points as a list, right? Okay, I select, you see one tool we have, list, right? I select the list tool and track all 5, okay? The mouse to cover all 5 points. Then you see in that algebraic view, L1 is the list of points, right? Now I'm going to, okay, find the fit polynomial of the line L1, set L1 with the degree P, right? Fit polynomial, right? L1, comma 3. Okay, so I use the command that fit poly in bracket L1. L1 is the list of points already created. 3 is the degree of the polynomial. So you zoom out, you will get the polynomial of degree. And below in the comment, you see the polynomial equation will appear, right? If I move the point A or B, the, okay, your polynomial moves, polynomial curve. Okay, in numeric analysis we have studied this as an interpolation, right? Suppose we have 5 points, then this curve is the interpolation of okay, interpolating polynomial of these 5 points of degree 3. So if I change the degree to 4, then okay, 4th degree polynomial, right? There will be up and down, 4th degree polynomial, right? always you see the x power 4 is non-zero now. Okay. Also, you can see the turning point of the. And the next toolbar is a polynomial tool, right? Polygonal path, right? I select a new polygonal. That polygon tool is you select several points, you will create a polygon, right? And the second tool is a regular polygon, right? Regular polygon is a polygon having equal sides. So once you select this one side, then the GeoGebra is ready to draw the polygon, but it wants to know the number of vertices, right? 4 vertex regular polygon is a square, right? If I, what is a polygon of 3 sides? This is triangle. What is a polygon, regular polygon of side 5? It's a pentagon, right? If pentagon is not visible, so you click on the graph and drag down, then you will see that. Okay, and the rigid and the vector polygon can be drawn. And the next tool is the circle tool, right? So this is a circle with the center through point, circle, center radius, and so on. Yeah. Semicircle arc can be drawn and so on. And the next tool is ellipse, hyperbola, the conic section tool, right? The last some one is angle, distance, area can be found, slope, and so on. And the next one is reflection, rotation can be done for some objects. Suppose I have a circle here, I take a straight line. Okay, if you want to find the reflection of the circle about the straight line, use the reflection tool. Okay, reflection object in line. Okay, I select the circle by tracking, right, and I select the straight line. Then you see the, okay, first circle is here C, second circle is C dash, right? It cannot be moved. This second circle is the reflection of first circle. Okay, it's like a mirror. So you consider that this straight line is a mirror, then it's a mirror reflection line. Suppose I move the circle, okay, the reflection also changes. So wherever I track the circle, reflection changes, right? And also you can reflect about point, reflection about circle also you can do. So now I'm going to find the reflection of line, okay, about circle. Then what happened is, select the reflection about, select the straight line and select the circle. What you see, reflection of the straight line is a circle inside the circle. Okay, that is more advanced, so you don't want that. Okay. And also in the last one, you can move the graph, zoom out, zoom in. Okay, I have used move graphics view, it can be moved. Okay, suppose something is not visible, you move the graph so that it will be visible in the computer. Zoom in tool used to zoom. Okay, by clicking, you can zoom in. Use zoom out tool to, okay, just by clicking on the graphics, you will see that it is zooming out. Okay, now I'm going to show you some of the some activities, okay, which is studied in the school days, geometric activities. Okay, so first I'm going to show you how the Thales theorem statement can be written, okay, prepared using that geometric construction. So for that, I take a line segment, using segment, and use semicircle tool, right? I'm going to draw a semicircle between AB, right? A and B. You have semicircle passing through AB. And I'm going to take a point on the semicircle, right? This point is C, right? So I'm going to use a polygon tool to draw polygon between A, C, B, right? I select polygon tool. Now I have to select vertices of polygons A, C, B. I have to complete the polygon, so that I have to click again A and A. Then we have a polygon. 3 polygon is nothing but a triangle, right? Now you measure the angle between ACE, right? So ACP. So what is the angle? 90 degree, right? The angle between ACE is 90 degree. Zoom. I have zoomed the triangle, right? 90 degree. Right? I'm going to use the track test. I'm going to okay, move the point C. The point C is on the circle, so it will not move out of the circle. So it moves along the circle only. So when I move the point C, what you will observe that the angle never change and it is still 90 degree, right? So that is the Thales theorem. So what is that Thales theorem? Okay, if we have a triangle whose one side is the diameter of the circle, the opposite angle is 90 degree, right? That is the Thales theorem. And also you can create a right angle triangle in this way. Suppose I move the point A, okay, as convenient, then you see this is a right angle triangle. I'm going to hide the circle, semicircle I don't want. So right click on the semicircle, right? You see show object, show label. Remove the show object, that disappears, right? So now you see the right angle triangle. Right? Now in the beginning we drawn some line segment. I'm going to remove the line segment also. You see F is the line segment between AB. In the algebraic way, you see the left hand side one button. Okay, this is the visible button. Okay, if we click on the button, it white color comes, means invisible. It colored button means it's a visible. Okay, I clicked and it disappeared. Okay, colored button disappeared. That line segment disappear here. Right? Now use the track test. Suppose I move the point C, okay, it will not move in. Okay, it moves on the circle. Already the semicircle is disappeared in this activity, right? Okay, always you will get a right angle. If you want to draw a right angle triangle, here there is no tool, right? So we have to create our own tool to find, okay, draw the right angle triangle using this activity. Okay, once okay, up to now I have stated Thales theorem. What is that theorem? If we have a triangle, if one side is the diameter of some circle, then opposite angle is 90 degree. So you get a right angle triangle. Now I'm going to create our own tool to draw a right angle triangle using this activity. Right? Here there are several objects we have created and automatically the computer creates. A, B are the points we created, right? And C is the diameter of circle, C is the point on the circle, right? So the connecting these points is a right angle triangle. So I'm going to create our own tool. Okay, you go to menu bar, then tools. Okay, you see customized toolbar, create a new tool, manage toolbar. I'm going to create new toolbar, right? This create new toolbar, our output is point C, but not point C, we want right angle triangle. So you, okay, click the drop down menu, you will see triangle ABC, polygon ABC, right? So I click, so our output must be a point. Name this as triangle, right? Then you finish. Okay, next to the move graphics view, we have a tool, right? This is the tool I created now, right? Now select the tool, then I am going to select 2 points, then immediately this tool creates a right angle triangle. I select hypotenuse, then okay, it creates so in this activity I have to create a hypotenuse so that other sides will be created by the computer, right? So in the graph DEF, right, the right angle triangle is at the point F, right? So I track this point, so you will get a perfect right angle triangle. You see that right angle triangle, right? DEF. Now verify the angle between, okay, each line, each pair of line, right? I clicked on the center of the triangle using the angle tool used to find the angle, okay, of the polygon. Now you see that angle between each, okay, pair of line segment. At each corner we have angle. In this corner F, angle 90 degree. So this triangle is right angle triangle. Okay, and also you can learn that sum of angles of triangle is 180 degree, right? So I'm going to use that too. Don't save. First you create a triangle, a random triangle, right? Using polygon tool, right? Then we measure the angle at each corner by selecting angle. Select the angle tool and click in the center of the triangle. Okay, immediately the computer gives you angle between angle at each corner, right? But now angle is visible. You just move that angle. Now we find sum of angle, right? In the input bar I'm going to write alpha plus beta plus gamma, right? Some I have written in the input bar. See below the, okay, bottom left of the screen, alpha plus beta plus gamma. I put enter. Then it, okay, the answer is 180 degree, right? Sum of angles of any triangle is 180 degree. Okay, that is the statement we know. Now I am going to show you how it works, right? Through the GeoGebra. Now we move the point C, right? Angle changes, but sum of angle never change. That can be displayed in the graphics view also. You go to the slider tool and you take the text tool, right? Click the text. Now I am going to create sum of angles of any triangle, okay, equal to. So I go to select alpha, beta, gamma. Okay, in the drop down menu you see alpha plus beta plus gamma. Good, okay, right? That is equal to, you edit this, right? Edit, that must be equal to, the sum is delta, right? Here is in the, see in that algebraic view, delta equal to alpha plus beta plus gamma, that is 180 degree. So I have to select delta also, then equal to delta. I think it is clear. In the text, this menu is used to insert text, right? I select the tool and I write sum of angles of any triangle equal to alpha plus beta plus gamma equal to delta, right? The alpha, beta, gamma, delta are selected from GeoGebra objects, right? I click OK. I see in that graph, right? What I have written displayed here, sum of angles of any triangle is, for this triangle 30, 97, 52 and so on, that sum is 180 degree. Now I am going to use the move menu to change the triangle. I change the triangle, but you see still the sum is always 180 degree. Okay, how much time I can take? May I take 2 more minutes for stop discussing the 2-dimensional geometry? I'm going to take 3-dimensional GeoGebra, right? I use new window. Okay, you go to menu bar and view. The view algebra graphics are selected. The algebra, you remove the graph and select 3D graphics. Then you will see algebraic view and 3-dimensional geometric view. Okay, okay. If I type any equation here, right? Y equal to x plus 2. Then This is in 3D, actually it's in 2 dimension, it's a equation of straight line, but in 3D it's a equation of plane, the blue color line. So if you want to draw circle, you type the circle equation, right? X square plus y square plus z square equal to 1. Okay, so you see, you remove that plane, you see this, you get a circle, right? With the center 1, sorry, with center 0 0 0, radius is 1. If I change the radius, then you will get a bigger circle, right? So here also there are several tools. Okay, intersection tool, you can draw plane, you can draw a sphere, okay, cones and cylinders and so on. You can also, okay, any single Cartesian equation gives a surface, right? So I will give you one demo. Suppose I write y equal to x square, right? In 2-dimensional space, in 2-dimensional geometry, y equal to x square is the parabola, but here you will have parabolic cylinder, right? So just what you see is the xy plane intersection with the parabolic cylinder, is the 2-dimensional geometry. Here you have parabolic cylinder. You can track the, in this 2-dimensional, in the red color axis is x-axis, y color is green color is y-axis, blue is z axis. Okay, so you can type any equation in the input bar, you will see the corresponding surface, right? Suppose I write x square plus y square equal to z square. I am not writing this, right? What is that? It's a double cone, right? You see 2 cones, one above the xy plane, one below the x. This is the cone below the xy plane. This is the cone above the xy plane, right? If I add some more numbers, right? This is called hyperboloid, right? Hyperboloid. When I add 2, then you'll get a hyperboloid, right? Suppose I subtract some number, then what? Right? This is also hyperboloid, but it's a 2 sheet. One sheet is above the xy plane, which is okay visible now. You zoom out, you see there is another surface below the, so this is hyperboloid of 2 sheet. This is more advanced and 3-dimensional geometry. This surface we have studied, but not we have seen this visually, right? Just like in algebra we have studied geometry, but if you want to visualize the geometry, we can use GeoGebra as a tool for that. Okay, so there are many things to discuss, but time does not permit us, so I stop here. Thank you very much, sir. I thank the organizers for giving me the opportunity. Thank you very much, sir. Now I stop.
Good evening. It is my privilege to welcome our resource person, Dr. V.Piramanantham, Associate Professor, Bharathidasan University. It is a great honor to thank our resource person, Dr. V.Piramanantham, for giving such a nice presentation. I thank our chairman sir and MD sir. I am very happy to thank our AGM and principal, Mr. J. Manimaran sir. I also thank our vice principal, Mr. P. Sagaya Arakira sir, and AO K. Murugan sir. I thank all the participants for making the webinar a grand success. Thank you.
Participants, feedback form was posted in a chat box. So first fill the feedback form, then you will receive your e-certificate through the email address. Thank you.
Hope you liked our webinar today. Do subscribe to our channel and click on the bell icon below. Notifications would be sent to you when new webinars are conducted, as well as when new events regarding our Polytechnic would be organized. Follow us on Instagram, Twitter and Facebook as well. Have a great day. Stay home and stay safe.